All right, so let's go ahead and try to see if we can actually do another one of these nice extended Euclidean algorithms, and we'll try to do it by hand, and then we'll bring about some nice technology to actually show how all of these pieces can actually come together. So in this case, let's make up a pair of numbers that don't happen to be coprime. So in this case, let's look at, I don't know, something like 330 and 228. So those two numbers are not coprime. You can for sure see that they have a common factor, in this case of 2, but they may have some other stuff as well. So we're going to see what they actually have in common by running the Euclidean algorithm on these things. It's also going to give us information about those quotients, which we can then use to back substitute in this nice little grid technique to ultimately see the solutions u's and v's to that actual equation that says 330u plus 228v equals whatever the GCD ends up being. So running this Euclidean algorithm, I'm going to see my first division stage. So let's rewrite this. So 330 and 228. So I know that 228 is only going to go into that thing once, because 1 times 228 ends up being 228. I'm off by 2 to make the 30, and I'm off by 100 to make it 330. So I get a remainder of 102. Running that again with the pair 228 and 102. I know that I am going to have 228, and what? We have 2 times 102, which makes 204. So I'm, what, 24 short to make it 28. So I'm going to take this 102 and run it with the number 24. In this case, 25 times 4 is 100, so 24 times 5 is pretty close to 100. So I'm going to have a 4 times 24. In this case, I'm going to be, what, still short by about 6 or something like that. And what do we have left? At this stage, we're going to be done actually now, because I have a 24 and the 6, and those are going to work out nicely. I get a 24, which is 4 times 6, and then I do in fact see my remainder of 0 now take shape. So I know that this process is going to terminate after 4 steps. So that becomes that t value that I care about later. So there are 4 total divisions that were utilized in this overall process. I know that my GCD ends up being a 6 because that was my last non-zero remainder. So the equation that we're eventually going to try to solve is 330u plus 228v equals a 6. The way that I can see these is using that nice little grid technique. So let's try to see if we can actually run this. So I'm going to make this little grid. I'm going to do it by hand. So we're going to hopefully see some decent looking letters take shape, but no guarantees while trying to draw on this little screen. So I'm going to have those first 2 cells which just record the 0s and 1s to initiate the p's and the q's. Then I'm going to have this row at the top, which is going to be all of those little quotient values. And those 4 quotient values are C, happen to be 1, 2, 4, and 4. So I'm going to put those up there. So 1, 2, 4, and 4. And now I begin this process of doing this sneaky multiplication. So number on top, number to the left, multiply them together, add the 1, 2 to the left. So 1 times 1 is 1, adding a 0 makes a 1. The next bit's 1 times 2, which is 2, adding the number to the left makes a 3. Next bit is 3 times 4, which is 12, adding the number to the left, and that's really tall. Go back. So 3 times 4 is 12, adding the number to the left makes a 13. And that's the one that I'm actually going to care about, because this is at level, this is Q1, this is Q2, this is Q3, and that's Q4. Because it took 4 divisions, I'm going to care about everything that was at the 3rd level. So in this case, that's going to become the P3 term that I'm actually interested in. But if I wanted to go one more step farther just to see what number takes shape, it's worth looking at now. So if I took the 13 times the 4 and then added a 3 to it, I think it kicks out something like a 55. And then if I fill in the Q values, I'm going to have 0 times 1, which is 0. Adding a 1 makes a 1. Next up, 1 times 2 is 2. Adding the next number, which is a 0, makes a 2 there. What do I have here? 2 and 4 makes 8, plus 1 more is a 9. That's the other value I care about. That's the Q3. And then last but not least, I'm going to have 9 and 4. And then I'm going to add 2 to that thing, which is, what am I going to have? 36, 38? As my final little cell in there as well. So the interesting thing to see at this point, just to kind of connect it to that last example, is that when we have a GCD of 1, we ended up seeing the values A and B occur in that very last column. In this case, my very last column has a 55 and a 38, which is not what my values A and B happen to be. But if you look at them a little bit more carefully, what you can see is that that 55 is connected to the 330. It's actually 330 divided by 6. Likewise, if I took 228 and divide that by a 6, I do in fact see that this number of 38 emerges. So you can see that these things are not quite the A and the B value, but rather they actually end up becoming these A's and B's divided by the GCD. Which, if you remember earlier, is actually one of the connections that people like to make, is that if I have this original equation, if I divided everything by a 6, I would actually be looking at the equation 55u plus, continue recording, go back. Sorry, but that I would end up having the 228, which is going to then become a 38, and then that's going to be with the v equals what? A 1. Okay, sorry, I got thrown off by that by it kicking me out for a second. I bumped one of the buttons and then it threw me out for just a second. So to backtrack now that I'm not frantically thinking about my computer going away, what I end up having is I'm going to have this equation that we start off by looking at, which is 330u plus 228v equals 6. Because all of those things happen to share a 6, I can divide everything by a 6 and end up looking at this little equation. Likewise, it'd be the same game as that if I wanted to try to find the GCD between 55 and 38. I know that these things are actually co-prime with one another, so I would see this nice little 1 actually take shape. But what's nice about this is that I don't necessarily need things that are co-prime. I can do this with things that are not necessarily co-prime. You don't get this nice A and B emerging over there, but you get things that are at least closely related to them. Okay, so now let's go back to actually thinking about what U and V are going to end up being. So in this equation that we have over there. So let's throw that one away. Just cover it all up. Okay, so what we have is we have that this thing required 4 total divisions. So my t value is a 4. So if we go back to our little formula for what my u is supposed to be, my u is supposed to be -1 raised to the number of divisions. So in this case, it's 4. And then it's going to be a q3. So I'm going to see that take shape here. It's going to be a -1 to the 4 multiplied by a q3. For the v1, it's going to be a -1 to the 5th. Like I said, it's just going to be the opposite sign of whatever the u was. So in this case, -1 to the 4 is going to fire off an even exponent, so it's going to become a +1. This one just needs to then become an odd exponent, so it's going to fire a -1. So in this case, it's going to be multiplied by the p3 term. So at the end of the day, I'm going to get a 1 multiplied by a not the 13, multiplied by the 9. And then over here, it's going to be a -1 multiplied by the 13, which becomes the solution 9 and -13. So if you wanted to go back and check, you can in fact see that if you took 330 and multiplied it by 9, you'd get something like 2,970. And if you added that to 228 times a -13, it does in fact kick out that final answer of a 6. That is, if you look at 330 multiplied by 9, plus 228 with a -13, that does in fact kick out a 6. So yay, it does work.